Okay, our objective today is that we will transform our rational expressions, okay? Remember why we call it a rational function, and that is because the x is in the denominator. And we look at this as the parent. Remember, we look at this as the parent because it is in its basic form. We have not transformed it anyway. We haven't multiplied anything with it, added anything to it, or shifted. Okay? All right. So we put in the f of x. We put that into our y1. You guys put that into your 1 over x. You got some values out of that. What value did you get for 0? You got an error, right, for 0. So, in essence, that means what? It's not going to cross the axis because x cannot have a value of 0, right? Because that would make this parent what? It would make it undefined, all right? So you filled in the rest of those numbers. I'm just going to put a couple of those in. The 1, you got a 1. And the negative 1, you got a negative 1. So we'll plot those. The 0.25, you got a 4. And the negative 0.25, you got a negative 4. So the 0.25 over here got you that 4, so he's kind of swinging up. All right, and then over here, your your negative 0.25 gave you a negative 4, so he's swinging down here. So that kind of gives us enough to graph this. Okay. And we ended up with those hyperbolas, didn't we? Just like when we did our inverse relation, okay? Because that is that parent. So we get that hyperbolas, we get that swing because of this error, right? Because where does x equal 0 on the coordinate plane? Where does x always equal 0 on the coordinate plane? Yes, in the origin, but where else? Which axis, Peter? The x-axis or the y-axis? What's the coordinates of this point right here? 0, negative 4. What's the coordinates of this point? 0. So y-axis. Okay, so we're going to draw that in as our asymptote. Okay. So you see how the hyperbolas got really, really close to that y-axis but did not make it, right? So we consider that one to be our vertical asymptote. That's our vertical asymptote. That's of the parent, right? Now, when we start shifting, it will shift off of that. But as the parent, that's the vertical asymptote. Okay, you also see what's happening on that x-axis as well. What's happening when it gets close to that x-axis up here? Is it reaching it? No. And is it reaching it here? No. So your x-axis is the horizontal asymptote. Okay, in this case. Remember what your asymptote is. It is a line that your graph approaches but never reaches, right? Your asymptote. A line that the graph approaches but never reaches. And when you're on the calculator, you'll see that happening on the calculator because the numbers, as you get to that error or to that asymptote, the numbers will either get extremely large or will get extremely small. And you saw those when we did the logs and the exponentials. You started getting those long decimals, which were really, really, really tiny numbers, right? Okay. So our asymptotes on our parent are the x-axis and the y-axis. Our our asymptotes play a very important part when we try to find our domain and range. This is a pattern that you need to make sure that you understand. So if I'm looking for my domain, if I'm looking at all those possible values of x, what are all the values that x can have? Can it have all of them? No. What can it not have? 0. So if we are looking at our horizontal asymptote will show us or help us to determine what our domain is. Okay? So in this case, our domain are all the numbers except 0. So x cannot be equal to 0. And for our range, if we look, now we're looking here, all of our y values. Can y take on all of the y values? No. Which one can it not have? It can have all of them, but right here, right, 0. So our range, let me circle that, y cannot be 0. Okay, let's take a look at the first graph. Where is the vertical asymptote on the first one? At 2, okay. So there's your first one at 2, so you're vertical. Where is the horizontal?
0.
At 0, okay. So there's your 2 asymptotes. So from your vertical asymptote, you get the domain. So what can x not be?
2.
And from the horizontal, you get your range. What can y not be equal to? 0. Very good. Okay, let's look at our second one. What is your vertical asymptote on the second one?
-1.
-1. And what is the horizontal?
2.
Okay. So looking at your vertical asymptote, what can your x not be?
-1.
It cannot be -1. And your y cannot be 2. And our last one. Where is your vertical?
3.
3. Where's your horizontal? -2. Right. Looking at your vertical, what is the restriction on your domain?
3.
And what is the restriction on your range?
-2.
-2. Okay. Questions on that? So you can can you see when you're looking at it, you can see the asymptote, you can see how that little hyperbola is getting closer to it and not reaching it? Yes or no? All right, so let's recall what we know about the A. What does the A, so here, the blue, if you guys look at the blue is the parent, and what's happening with the red and the green? What are we doing to it? What does the A do? It stretches and compresses, right? So we have our A, which does the vertical stretch and compression. Or what else does he do? Yeah, if I'm right here with my blue ones, I'm in quadrants 1 and 3. Now let's look at these brown ones here. These brown ones are now in quadrants 2 and 4. So what do we do to the blue one? Reflected, right? So remember, your A also reflects. Okay. When do we know we're going to have a stretch? What's the value of A when we have a stretch? Greater than 1. When do we know we're going to have a compression? When A is less than 1, but still greater than 0. And it will reflect when A has a value of what? Negative, right? So we would say when A is less than 0, right? Or negative. Thank you. All right, and our next one is our H. What does our H do to our parent? H for horizontal, right? So remember, you have a horizontal shift. Okay, so it's going to shift it left to right. Look at your blue. Look at your original parent there. Okay, if we looked at our red one here, we see that we have shifted him off to the left, right? So if we start off with our blue, we see that that is, let me see if I can draw it in, that's actually that x-axis, right? I'm sorry, y-axis. So if I shift this blue, if I shift this red one, what am I shifting with it? Do I have a new asymptote? Yes, now I'm over here. If this is my y-axis now, where is my new asymptote? What's that value? Count over. How far did we move? 2, right? So that would give us a new asymptote. Let me see if I can draw that one in. There's the new asymptote, right? So the vertical asymptote shifted left, or it will shift right. Okay, when do we go right? We need to word this carefully. Word it the way you're going to remember it. We move right when we see what? A positive, okay? And we move left when, no, no, hold on. We move right when it's negative. And then we move left when it's positive, right? Because it's a flip. Remember that x minus h flips that sign, right? Write that up a little higher. Okay. And we see that in looking at this shift up here, that your h will determine your vertical asymptote. And vertical asymptotes determine our what? Domain or range? Domain, thank you. And it will determine our domain. Very good. All right, and here's our K. What does our K do? Vertical, so it shifts it up and down, vertical shift. It moves up when K is positive, and it moves down when K is what? So if we start with our parent here, where this is our x-axis, I'm going to move. Let's look at the red one. Let's look at the red one. Did we move this red one up or down? You see that? Where did we move that red one? You see where the new asymptote is right there? Okay. So it's now at, so now it's at 2, yes. So your vertical shift affects your horizontal asymptote. And horizontal asymptotes determine our what? Domain or range? Range. Okay. Questions on that? Okay, so let's look at our first one. Where is your vertical asymptote?
At 3.
At 3. So they show you. So we should have a new vertical asymptote here. What about our horizontal? Horizontal. So your horizontal did not change, right? So what changed was the vertical. Remember, it is the h that determines that. So that would be 1 over x what? Minus, we went to the right. Minus 3, right? There is no k because we didn't shift that horizontal, so we're good. So what can x not be?
3.
3. And what can y not be?
0.
Okay. Now, to show this in interval notation, I'm going to come up here at the top. You would go in, I'll just do the x. You're coming in from that negative infinity, right? And then you have to make a stop right there at that 3. So you would do negative infinity to the 3 and or union, and then what happens is we have to stop there and then we pick it back up. So we start back up on the other side of 3 and we head out to positive infinity. So that's what it looks like written as your interval notation. So you'll see it both ways.
Do we have to write it?
I would go ahead and write it so you'll know, because if you see it again, you're going to know that, okay?
That's for. How do you draw the lines?
That's the interval notation. Do what?
Nothing, I got it.
Okay. Okay. Where is your, on your second one here, where is your vertical asymptote?
0.
0. So that means we did not, it's still on the axis, so we did not have a horizontal shift. What about your horizontal?
Positive 1.
Positive 1. So we did do a vertical shift. So this would be 1 over x, and that's all, right? We didn't horizontal. So what's your k? Plus 1. All right, very good. X cannot be, and y cannot be 1. And our last one, what's your vertical?
Negative 1.
-1, okay. So we did have a shift horizontally, so that would be 1 over x
1 plus 1.
plus 1. We went to the left. Horizontal asymptote.
Negative,
2. 2. So it would be what? What's your k?
Plus 2.
We went up, so it would be plus 2. All right. What can x not be?
Negative 1.
-1. Y cannot be 2. All right. Any questions on that? Okay. Very good. We'll stop there.